Probably the best way to describe it is it does everything for overhead line design. And as I mentioned earlier, we're talking surveying, terrain development, foundation design, geotechnical, structural analysis and design, wire stringing, sag tension analysis, of course, with all the construction reporting that's required so that the linemen and the folks in the field can build a line, all the way to documentation, and of course today with GIS and the digital twin being the digital twin of what was built out there. So we pretty much handle all of that. I mean, we're both the horizontal and the vertical company. We're horizontal. Everything we do is broad. People say, okay, buy our software. What other programs do I need to buy? And, do I need to buy another sag tension program? No, we got it all. Do I need to buy a foundation program? No, we got that. Do I need to buy something to handle the mapping of my GS application? No, we got that too. So we kind of do it all. And so in a nutshell, that's what we do. Of course, I can go deeper, but in a nutshell, that's what we cover.
It's a lot more complex than most people think it is too, isn't it? I mean, just calculating the catenary curve of a conductor is one thing, but then now putting it on a structure that's moving around is another thing, yes. And being able to take into account the temperature changes, yes. And how that affects the wire. All that's built in.
It's all built in. Thank you. And golly, it's amazing. People think that transmission, you're just stapling wires to the poles. No, it's so complex. I mean, my son's majoring in mechanical, and what do they tell you in mechanical engineering? Don't mix two metals. And what do? We take a steel core and wrap aluminum around it and then change the temperature up to 300 degrees Fahrenheit. Mm-hmm. We break every rule on that comes in, but that's what we're able to calculate as the wires heat up and cool down, the change in the different metals and how they behave, as well as wind blowing out the conductors and ice on the conductors and combinations of wind of ice, and especially in today's world with the vegetation analysis. And, the wires don't stay where they are when you go survey them. Yep. We have to know when it gets hot, when we're having those hot days in September like they are in California right now, how far is that wire going to sag down? Yeah. When you get that, maybe not a Santa Ana wind, but when you get a strong wind combined with that, mm-hmm. How far is that wire going to blow out? Is it going to blow into the vegetation, the trees, or hit too close to the ground? And that's what we do. We can create that entire wire movement envelope. And as Wes said, it's not just the wires moving, it's insulators swinging out, and it's poles deflecting. Yep. A pole can deflect 10, 12 feet easily underneath a higher wind. So add that 10 or 12 feet to a wire that's blowing out 30 feet, you're outside your right-of-way all of a sudden.